Good morning, dear colleagues of mathematics in the province of Yakutsk. I've been asked to give the answer on the question of the moving arctic circle, moving only for 1 meter southbound, but nevertheless. And the question was, the second arctic circle, how much longer is the other one compared with the other one? Well, therefore I brought you to the beach of Holland. Over there is England, and behind me is the rest of the country. It's quiet now. It's 6:30 in the morning, and I'll try to explain how I found out the solution. Thank you very much for all your effort. I've had wonderful pieces of mathematics, and I brought my small classroom to the beach. Let's see what I brought. Of course, a board to figure out things, an umbrella, not for the rain, but the umbrella stands for the northern part of the Arctic Circle. You see, this actually is the Arctic Circle, and that's the top of the Earth. A ruler, well, a globe. I brought your work. Look at all the things you have done. Impressive. I've made prints of them, and I brought this one because this one is going to demonstrate where the North Pole is. Just imagine we are now on some part of the globe. I'll put it right here, like that, and this is the North Pole for today. And I'm going to draw the Arctic Circle. Let's see, something like that. This is the Arctic Circle. Well, North Pole should be in the middle, of course. And the question was, what's going to happen when you bring the Arctic Circle 1 meter more down? And here on the beach, it's obvious that the second one is longer than the first one. Must be around about 1 meter, is it? Something like that. That's the original Arctic Circle, and this is the new one. And the question is, how much longer is he? Well, a few answers, and initially it's also what I thought was 6 meter and 20 centimeters. And well, the answer was 6.28 meter. And the idea was, imagine you have a circle and another one, and this is 1 meter. The inner circle, I call it circle number 1. Can you see it? Circle number 1, 2 PR. The other one, number 2, is the same, 2 pi r plus 1, because it's 1 meter extra. I'm going to work this out. This makes 2p r plus 2 pi, and I have to subtract this one from that one, minus this one, 2p pi, which is round about 628. But that is not the case. Why not? I brought you this thing. Oh, sorry. Look at that. It's a nice pot, is it? The radius is not extended. What I've done there is extending the radius from here 1 meter up. But it's not 1 meter up, it's 1 meter south. So we've got two radii. One is here and one is there. And all we have to do is find out what is the radius of this one and that one, and then what's the difference. But that takes quite some calculations, but let's go first step by step. What we should know is a few things, and I've written it all down. A few assumptions. The Earth is exactly round. Assumption. It's not, of course. The Earth is flattened a bit. It's 28 kilometers more down than broad. There are no mountains. There are no seas. It's like a billiard ball. Which is not true, of course. But for the maths, it's a perfect bowl. Another thing is, the equator is 40,000 kilometers, or otherwise 40 million meters. And that means it goes like that, and like that, and like that. Around the Earth is 40,000 kilometers. Another thing is, where is the Arctic Circle now? I've done some Wikipedia things, and I found out that the Arctic Circle is going up and down a bit. It differs on the moment. A few hundreds of degrees, but it differs. I looked it up where it was yesterday, the 17th of May, and I was told that it was on the latitude Arctic Circle 66 degrees 33 minutes 47.2 seconds. To give you an impression where that is, I brought the globe. Let's see. That is where? Yes, here. No, this one. This is the Arctic Circle, and the Arctic Circle goes a bit up and down. And now we are assuming that the Arctic Circle should go down 1 meter, which is nothing on the globe, and which is actually nothing in reality, because just imagine, I mean, it seems flat. It all looks so flat. But okay, I've been trying to find out what it means when it goes down. Another assumption is pi. Normally we reckon pi with 3.14, but due to the fact that we've got such a very small scale on which we are doing maths now, we need to have pi as exact as possible. There we go. And I've been using Excel, of course. I have been figuring out all these things by hand. Is 3.1459265389700. And meaning 2 pi, of course, is the double. 2.8, 2.28, etc. These are the assumptions, so it's completely flat. We're going to use that pi, and the artic circle at this moment, or yesterday, is at this height. Great. There we go again. The Earth with the artic circle. It looks a bit like a potato. That's the middle of the Earth. And this is the second one. What we have to find out now is this radius. This one. How long is that one? Center of the Earth. Equator. And we have to find out this one. That's why I used my umbrella. This is not the radius we need to have. So, from here exactly to there. That's the radius we have to find out. And if this is the middle of the Earth, we can draw a line from here to there, and this is a rectangle. So we can use geometrics comparisons, and we're going to use the cosines. This is a triangle. We know this one. That's 40 million divided by 2 pi. That's the length of this radius. Also this radius. And we know, of course, also this angle. As this is on this latitude, I've made this decimal, and that leads to, where is it? Well, sorry. This piece is 10 million meters. We can divide 10 million by 90 degrees, meaning that 1 meter is 0.1, no, 1, 2, 3, 4, 5, 0 degrees on the curvature of the Earth. Meaning if I do this, or that, I'm going down, downhill. Let's see exactly, please. I brought a compass. The compass tells me that is north. Where I'm pointing it now, that's north. So now I'm climbing up the Earth. And now I'm going down to the south, heading to the equator, and with each meter I'm getting closer, and I need to have 10 million meters to reach that point. Good. Thanks to Excel, I could find out the cosinus of this angle. How many degrees is it? It was, where is it? Did I write it down? Here it is. I made it decimal, so that leads to 66 degrees and 5, 5, 7, 8, 3, 3, 3 degrees. Okay, we can find the cosinus of this one. The cosinus, I found it in Excel, Microsoft Excel, is, there we go, 0.99372373925. Good. That's that one. And now the new artic circle, which is this one, which is 1 meter down, which is so many degrees less, so we have to subtract that. So the new artic circle is this minus that one, and that leads to a cosinus of nearly the same. There we go. Here, the new artic circle. Oh, this is a 3. 0397. There should be a 3 in here. 0 3 9 7 8 2 3 3. So far it's still the same, but now look at that. There we go. 3 4 4 6 5 8 8 5 3 0 0. Up to so far it was the same, but now it's going to differ. Good. We know the cosinuses. We multiply the cosinus with this radius, and then find the radius of both the artic circle and the new artic circle. The radius of the artic circle, this one multiplied by this radius, and this radius is that one, 40 million divided by 2 pi. The radius of the artic circle is, there we go, how many meters? 2, 2, 5, 3, 6, 2, 2 point. So many meters? 25,000, 25, let's see, 2,500 kilometers. Is that realistic? Well, yes, of course. And it means 2,500 kilometers downwards, that way. Not that way, down into the umbrella. Tube, and then comma. The dots. 2, 5, 3, and then a 2. I'm going to send this sheet of paper with all the exact data. 6, 1. This is the new one, the old one. And then 1, 6, 6, 0, 1, 4, 9, 3, 0, 0. And the new artic circle, the radius, this times that one, makes 2, 5, 3, 2, 6, 2, 2. There we go. 0, 8, 3, 4, 7, 6, 9, 9, 0, 0 meters. That means, in short, radius of the new Arctic Circle is 1 meter longer on a scale of more than 2,500 kilometers. Well, and then we have, of course, once we have both radiuses, it's just a matter of calculation. Where are we? I'm going to send this to you. Well, I can show you my calculations here. The new Arctic Circle is that one, and the difference is 5.76458417 meters. That means a lot of students and colleagues said that I was stupid and doing nonsense things, but it is relevant. It is relevant. Why? Just imagine you want to make a railway over the Arctic Circle. Then you have to realize that the rails on the right side are 5 meters 7 and 70 centimeters, 72 centimeters longer than the other one. And of course, it's very simple. If you look at the North Pole, our North Pole here on the beach, you can see that the inner circle is shorter than the outer circle. There's only one place on Earth where you can have both lines parallel, which is on the equator. If you're going to build a railway here, you've got no problem. The problem is here. Good. To summarize, the question was, how much longer is the new Arctic Circle? And the new Arctic Circle is 1 meter more south. One of the answers was, what do you mean with south? Covering the surface, or south in this way? Umbrella. South, does that mean following the Earth or going deeper? Of course, it's following the Earth. If I tell you that I'm going to walk 20 kilometers northward, I'm not climbing up the Earth. I'm always following the surface. What we needed to do is to find out the two radius of both the old one and the new one. And we did that by using the cosines of both the old one and the new one. How do we find the new one? Well, I divided 90 degrees with 10 million, and then I find out that 1 meter takes 0.12345 zeros 0.00009 degrees. And then, thanks to Excel, I could find out the cosines. By that, I had two radius, and I could find out the two lengths of both circles and then subtract them. And the answer is 5 meters and 72 something centimeters. I'm getting cold a bit, it's very early in the morning, and I didn't bring my coat, and I want to have a coffee. If there are any questions or remarks, or maybe I made a mistake, I will send this to Natalia, and Natalia, she will put it on the internet, on her website, or she will send it, I don't know what she's going to do with it. But if there are any remarks, please don't hesitate and write me. I'll give my email address. I can give my email address here, which is, there we go, T-O-N van Den Haag at Ziggo.nl. You can send it straight to me, or you can contact Natalia to give your critics, because I'm not super. but it took me a lot of thinking, and thank you very much for all the work you've done. And if you have a question for me, please give me a problem and let's see what we can do. Right. Thank you for all your work. My goodness, look, I was impressed. I don't know who this one was, but this is perfect. It looks very nice, but there were no measures in it. There was another one. Yes, this is the 6 meters and 28 centimeters. But the point is, it didn't go up, it didn't lengthen the radius, it went that way, over the surface. This is another, 2 times 314, which is also 628, which is not the right answer actually. But good thinking, good thinking. I see a flock of birds. Right. So far so good. I'm going back to my car and bring all the luggage over there. Bye, thank you.